What's up, you guys out there in pre-cal world? This is Mr. Putt coming to you live, even though I'm not really live because it's recorded. All right, anyways, there's not really that big of information to talk about until we get into something later on, which we'll talk about the average rate of change, as you can see. Yay, average rate of change. So really, I'm just going to get after it and start looking at some examples with you guys. So the first type of thing that you will see, this is called the difference quotient. So when you see the difference quotient, all this means is that we're taking the difference of two function values, right? Difference, and it's a quotient because it is a fraction. This is actually how you'll first learn things when you guys get into calculus as far as derivatives, but you don't know that right now. This is really not too terrible. So essentially, this is saying find f of a plus h minus f of a, all divided by h, as long as h cannot be equal to 0. So all this part is saying this h cannot be equal to 0 is saying that our denominator here is not 0 because we cannot divide by 0. All right, this first example I'm going to take a little bit slow to help you guys understand because it says f of a plus h minus f of a. So remember, if we saw like f of 2, right? Not really related to this problem, but if we saw f of 2 using our function f of x, well, instead of an x, we have a 2. So this is the same thing as saying 2 times 2 plus 3, right? Instead of my x and x, I have a 2, so I put a 2. And then we could simplify this function. Likewise, for f of a, instead of an x, we have an a. So instead of an x over here, I will put an a. So 2 times a plus 3, which then is still just 2a plus 3. Right? F of a plus h, right? That's our next kind of one that has the most stuff. F of a plus h, just like the last two that we've looked at. Remember, this one's not really related to this problem. Instead of x, I have a plus h. So my new variable, so to speak, is 2 times a plus h. So 2 times a plus h plus 3. And then we could even do the distribution property with our 2 there, so that this is 2a plus 2h plus 3. All right, so now I know what f of a plus h is, and I know what f of a is. So we can substitute these things. F of a plus h is that part, minus f of a, which is that part, so that we would look something like this. F of a plus h is 2a plus 2h plus 3. Now minus what f of a is. F of a is 2a plus 3. All of that divided by h. All right. So next step, it's just going to be simplifying this as much as we possibly can. We can distribute this negative such that we end up with 2a plus 2h plus 3 minus 2a minus 3. All of that still divided by h. All right. So then, 2a minus 2a makes 0. 3 minus 3 makes 0. All right. So we're left with 2h divided by h. Well, if I look at that, I know h divided by h makes 1. So I'm just left with 2. That's it. That's kind of how these solutions are going to be coming out. All right, remember, just a reminder, you guys can pause, you can rewind, you can do whatever you need to do to help yourself understand this video. So I'm going to start going a little bit quicker. Use this first example to help you understand. But like I said, I'm going to go a little bit faster so that we can get through all these notes in a reasonable amount of time. All right, looking at our next one, same sort of idea. F of a plus h minus f of a, all divided by h, as long as h cannot be equal to 0, and it's giving us our function now as 2 minus 3x. So f of a plus h, so I'll plug in a plus h where I see x. So now I have 2 minus 3 times a plus h. Now minus f of a, so minus when I plug in a for x, so 2 minus 3 times a, all of that divided by h. Right, I can distribute the negative 3, so I have 2 minus 3a minus 3h, and I also can distribute that negative, so minus 2 plus 3a. All of that divided by h. 2 minus 2 makes 0, negative 3a plus 3a makes 0. So I have negative 3h divided by h. H divided by h makes 1, so I have negative 3 in the end. Woohoo! All right, moving on. A little bit more complicated, but still not too terrible. It's really, really not that bad. Same idea. This is never going to change. This is your difference quotient, no matter what. Sorry, that's never going to change. All of this f of a plus h minus f of a. That's going to be an a. I'm sorry. F of a plus h minus f of a, all divided by h, and h cannot be equal to 0. So again, I'm going to plug in a plus h where I see my variable. So I have a plus h squared. Still a minus 4, so minus 4. Now minus f of a, so minus what f of a would be, which would be a squared minus 4. All of that divided by h. So now here you got to be careful. You got to remember for me, please, 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 please. Oh, I'm begging you. Remember that that is a plus h times a plus h. So when you distribute everything to everything, you're going to be distributing there. You will have a squared plus 2ah plus h squared. So a squared plus 2ah plus h squared. Now I'm copying. Minus 4. Distribute this negative. So minus a squared plus 4. All of that divided by h. Check it out. A squared minus a squared. Negative 4 plus 4. So I am left with 2ah plus h squared divided by h. Remember that both of these terms in our numerator are being divided by h. So essentially I can divide out h from both of them. So I have 2a plus h, and that is as far as I can simplify this function. Cool. Keep going.
Keep going, dude. Yeah, you're doing so good.
All right. I'm sorry. Never mind. I'll stop apologizing. You guys know I'm weird by now. All right. Again, find f of a plus h minus f of a divided by h as long as h is not equal to 0. If we're given the function 2x squared plus 3x minus 8.
Oh yeah.
So here I have two spots that I'm going to be substituting the a plus h and the a. All right. So I have f of a plus h. So 2 times a plus h squared plus 3 times a plus h minus 8. Now I have minus f of a, so minus what f of a is, 2a squared plus 3a minus 8. Oh yeah. All that still divided by h. Oh, happy day. All right, so again, a plus h squared is still going to be a squared plus 2ah plus h squared. Remember that's when we multiply out, right? And this last one we did shabadoo. We did all of this multiplied to be this part. All right, same sort of thing is going to happen. My sound effects make things move faster or slower, I don't know. So I still have 2 times a squared plus 2ah plus h squared. And then I can distribute this 3, so plus 3a plus 3h minus 8. Distribute your negative. Minus 2a squared minus 3a plus 8. All of that divided by h. Getting closer. Okay, from this part, we can at least get rid of our 3a's. So 3a minus 3a is 0, and negative 8 plus 8 is 0. Then I can distribute the 2. Oh, yeah. So I have 2a squared plus 4ah. 2h squared plus 3h minus 2a squared. All of that still divided by h. 2a squared minus 2a squared is 0, I do believe. And nothing else gets rid. So we're left with 4ah plus 2h squared plus 3h. That's all still being divided by h. So if this term is divided by h, that gets rid of that. Gets rid of an h, gets rid of an h. You have to get rid of h in every single term, as long as it's being divided by a single thing. Right? We could have factored out the h in the top, and that's how the division works. So we have 4a plus 2h plus 3. And that's what we're looking for. Just simplifying this as much as you possibly can. All right. The next concept that we are going to talk about is average rate of change. You guys have heard this before, I promise. I promise you a million times. You've heard of this before. You've done it in Algebra 1. You probably did it in Algebra 2. You probably did it in Geometry. You see this? You see this? I promise. Average rate of change is essentially just talking about, on average, from point to point, how much is our function changing by. So it could be going up. If we're going, say, this point to that point, notice our slope would be going down. So depending on what point we go to, right, if we have an x1 and an x2, remember this, f, that's just our output. So this is essentially y1, y2, right? And it doesn't matter whether you have f of x2 minus f of x1 over 2. Just notice, these go together. They're on top of each other. It's the difference in the y's over the difference in the x's. That's all its slope is. Rise over run. Change in y over change in x. All right, so that's all we're really going to be doing. So you'll see problems, something like that, where it says determine the average rate of change for each function over the given interval. So this is telling us it wants the average rate of change for this function for 2x squared plus 3x minus 4. So that'll look something-ish like that. I don't know where my zeros are, but it'll look something-ish like that. It's close. Over the interval 0 to 6. So it wants to know from 0 to 6, on average, what is the slope changing by? You don't have to graph this for me every time. That's no big deal. But what I want you to get to realize is it's going from an x value to another x value because it's given to you in interval notation. It's giving you 2 x values. Well, to find slope, we need 2 x values and 2 y values, so we can do change in y over change in x. Well, we have some x values, right? Can't we find y values from those x values? Because, don't forget, Algebra 1, Algebra 2, Geometry, whatever, even pre-cal, we've done this. You can evaluate functions based on their x value and find their y value, because it's just the output based on the x value. So if I have 2 times 0 squared plus 3 times 0 minus 4, that will give me an output of negative 4. That looks weird. That's negative 4 minus 4. Negative 4. Negative 4. Yes, negative 4. All right, and we can find f of 6. So this is the x value. So 2 times... I'm out of school. I'm leaving. I'll see you guys later. I ain't coming back. I'm leaving forever. I'm sorry. All right. So yeah, 2 times 6 squared. Remember, this is 2 times 36. Do not do 12 squared. Do not. All right. Squared. PEMDAS. Do the exponent first. So that's 72 plus 18 minus 4. So 72 plus 18, I do believe, is 90. Minus 4 is 86. All right, so essentially we have 2 points. We have 0, negative 4. We also have 6, 86. So the slope, or our rate of change, our average rate of change, could be 86 minus a negative 4, all divided by 6 minus 0. All right, so we have 82 divided by 6, that is not 82. What are you thinking? Minus a negative turns into a positive. So that's 90 over 6, right? Yeah, 90 over 6. My bad. I'm so sorry. I'm so sorry. At least I caught it before I stopped the video. All right, so that can be 30 over 3. That would be, no, that's not, what am I talking about? 30 over 2. That's 15 15. So essentially what that means is my slope from this point to this point, if I went in a straight line, I would have the line 15x minus 4, or whatever it would be, right? So the slope, the average rate of change, how much these are usually changing by from point to point, if I went blah, it would be like it's going up 15 every 1 unit. So my average rate of change, or my slope from point to point, is 15. It's just going to be a number. You're just getting a number here. All right, I don't like this paper. This paper smells funny. Get out of here, paper. I threw it across the room. Whether you believe me or not is up to you. The truth is all yours. I know, I'm sorry. I'm crazy. Crazy. I don't know what I'm talking about. All right. Again, average rate of change. 7 x values. All right, so again, we can find h of 5. We can find h of 8. They may not be pretty numbers, but it's no big deal. All right, so we have 3 times 5 minus 7 divided by 5 plus 1. Well, that is 15 minus 7 is 8. So I have 8 over 6, which is 4 over 3. Right? H of 8, 3 times 8 minus 7 divided by 8 plus 1. 3 times 8 is 24 minus 7 is 17 over 9. Ooh, we got some really ugly numbers. I should have thought about these. But again, same sort of idea. We can do 17 ninths minus 4 thirds divided by 8 minus 5 to get the change in the y's over the change in the x's. So in my numerator, in order to subtract these fractions, I'll have to multiply by 3 over 3 so that I get 12 over 9, and I can actually subtract those things. So then I have 12 ninths, or 17 ninths minus 12 ninths would be 5 ninths in the numerator, divided by 8 minus 5 is 3. So remember, when we're dividing, we can multiply by the reciprocal to get that this would be 5/27. That is my average rate of change from point to point. All right, same idea. One more problem. All right, so we have average rate of change. As you guys are going through this, sorry I'm reminding you now, but it's always a good idea to stop the video and make sure you try some problems so you can see the solution. Make sure you're doing it right before you really get to your homework or the quiz or the test, and not do so right. But remember, making mistakes is how we learn.
Making mistakes is how we learn.
I make tons of mistakes. I'm making a mistake right now by talking and not doing math. You're like, shut up, Mr. Pike, do the math, hurry up, I want to go home and go to bed. But you might be already home and in bed. So who knows? Who knows what's going on? I'll shut up. I'm sorry. All right, so we have t of, we need to figure out our y values. Well, I guess I'm late for class now. So 5 times negative 2 squared minus 8. 5 times 2 squared minus 8. Right? And this would be 5 times 4 is 20 minus 8 is 12. Again, 5 times 20 minus 8 is 12. Whoa, that's kind of weird. But it's right. I mean, they're both 5 times 4, so I got 20. Huh. Well, when we do it, we have our y values over 2 minus negative 2. 12 minus 12 is 0 over 4. Well, that just means our slope is 0. And if you think about the graph, 5x squared minus 8, that's just a parabola moved down 8, going up and up like that. It has been 14 days! Oh my gosh! I don't care. All right, so we're going negative 2 to negative, or sorry, 2 to negative 2. I think we're up here somewhere. I don't know. But essentially, we're going 2 to negative 2. Well, we have y-axis symmetry, so essentially the slope is 0 because it's not going up or down at all. They're both the same distance away from our y-axis. All right, hopefully this video has been helpful. I love you guys. Make a donut face monkey thing. Donut sprinkles and donuts. Yeah, he's dancing for you. I think he's dabbing or something, if you still know that. Either that he's like picking his nose. Who knows? Nose. All right, I'll see you guys later. Bye-bye.